is yellow, and then you start adding the base to it. Yellow, 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 and then it goes orange, and then it goes red. That is indicating that the solution has changed from acid to base at about a pH of 7. So that's what indicators do for us. Now, what about the next one? This is where I'm going to need somebody that's done the problem. I'm not looking up so as not to convict anybody. Seniors. Number 59. '59 is the titration of acetic acid with KOH. Weak acid, strong base. What do you know about the equivalence point pH for a weak acid titration? Say it louder. It's basic. Just in general, when you titrate a weak acid, it's going to be basic at the equivalence point. Why? Because all the acid is gone. All the hydroxide is just used up with the acid. Therefore, the only thing you have is what the other side of the equation has, the conjugate base. It's basic equivalence point, always. So what is, if anybody did number 59, what is the pH at the equivalence point? I believe it was point number E. Point number E.
Is it 8.78?
8.8, or say 8.78 is good. So what indicator are we going to use? Well,
let's use phenol red.
We're going to find an indicator that changes color around 8.8. Let's see if I can fit this all on the screen. 8.8 is about there. So we're not going to use any of these because they will already long ago have changed color. Some of these indicators aren't awesome. They have 2 different color changes. Don't use that though. Let's go all the way down to 8.8. Oh, I haven't gone down far enough.
He goes to
zoom out on this. It's going to be hard to read when I do it.
And now it will be hard to read.
Okay, so 8.8 is this. This indicator right here, phenolphthalein. That would be a great indicator to use for that titration. Or the one underneath it, thymolphthalein. So either of those would be good. So do you see what we have to do with indicators? Now remember that these color changes are based on what the pKa of the acid is. Acid meaning the indicator. So phenolphthalein has a pKa of around 9. Therefore, it would be good to use phenolphthalein when the equivalence point is a pH of 9. Methyl red has a pKa about 7. So it's good to use methyl red when you have a titration whose equivalence point is about 7. So when the pKa of the indicator is around the pKa, I'm sorry, the pH of the equivalence point, that's when it's a good indicator. All right, so that's what we do with those exercises. Just choose the indicator that works for that. On the practice test, there will be exercises about indicators, and so you can practice that. Just one other thing in this chapter. It's very simple, and that is polyprotic acid.
Oh my. Oh.
That may seem scary to you, but it is not scary at all. A polyprotic acid has, well, a diprotic acid has 2 hydrogens that come off of it. We assume that the 2 hydrogens come off. The second hydrogen only comes off after all the first hydrogens are gone from all the molecules. So you're going to get 2 equivalence points, one for the first and then one for the second. I'm going to be totally honest with you and tell you this I just searched for, and now that I reflect on it, it's not a good image, and I need to come up with a different one. Because in reality, in the lab that you do, you're going to do a diprotic acid titration. It's not going to look like this. The first hydrogen is going to have a steeper slope, or a steeper vertical region, and then the second one is going to be more gradual. I had told you last week that the weaker an acid is, the more gradual its equivalence point is. The second hydrogen is always weaker. So this shows you a very steep, very pretty equivalence point of the second hydrogen. You never get it with a diprotic acid. This is a fantasy. But anyway, we can do this. At least in the lab, you're going to be asked to find the Ka1 and the Ka2 of a weak acid after doing a titration like this. Diprotic. How would you find the 2 Ks? If you're given a titration curve, what do you do to find the K?
Talk about this last
Now I'm testing you again. Oh, wait.
The challenge.
How do you tell the pKa or the Ka of an acid based on its titration curve? Right, you got this?
Well, isn't pH equal pKa at the halfway point?
Oh yeah, that's exactly what I was hoping for. Very
Mr.
nice.
Moore is being creepy.
Did you hear what Barrett said? She said it quietly. Say it louder, Barrett.
Equals pKa at the equivalence point. Halfway point.
Thank you. The halfway point. The halfway point is a big deal because when you have an unknown acid, keep the camera on her. She's the star today.
You should stand up and cheer. Yay, Marat.
When you have a titration curve and you want to know what the pKa or the Ka is, find the equivalence point. It's right there. Find the halfway point. I don't know. It's right around there. Whatever the pH is. That didn't turn out very well, but you get the idea.
He too is a hater.
That is the pKa of the acid. pH equals pKa at the halfway point. Okay, now I got a question for you. What about that second hydrogen coming off? What is its Ka? Remember I told you that all the first hydrogens come up before the second ones start coming off. So the second Ka starts right there. How would you find Ka2 then for the second hydrogen? Do I start it? Do I go out there and just take halfway, which is about right there, pH?
Halfway from your new start.
Yeah. This is where, remember, the Ka1 starts right there, or ends right there. Ka2 starts there and ends there. So the halfway point is halfway from there to there, which I'm just going to eyeball is right there. Everybody catch that?
Yeah.
So for the second K, start at the end of the first. So this pH represents the Ka2. Another reason this thing is bad. If this is a diprotic acid, that has to be, well, I'm sorry. Oh, it is. I was going to say that has to be basic, and it is. I was thinking the halfway point has to be basic. This is good. Anybody have any questions about that? Okay, so I just need a couple minutes. I want to talk about the lab and what happens in the lab. We have 4 dates that are reserved for this acid-base titration lab. There's 3 parts to it. The 3 parts go like this. Part 1 is all theoretical. There's no experimenting to do. I'm going to say that it's a lab. I'm going to give it a lab grade, but you didn't do any experiment. I'm going to give you some data, and I'm going to ask you just to do this this exercise where it's a titration curve. You're going to find the pH at different data points of a titration. Actually, of 3 titrations. Strong, strong. Weak acid titration, weak base titration. So we're going to do 3 different titration curves. I'm going to ask you to find the pH and graph them. That's part 1. You will have some time during class to work on that too. That's going to be nice. What's that, Brian?
Did Satan give you this plan?
It's not that bad, is it, Brian?
It sounds like a lot of work. Yeah, there's probably like 4 parts within each part.
Oh, no, there's about 10.
This is even worse.
10 points within a titration. It's all good. You get real nice information out of it.
They
So
smile
your
at
work
the
is like a
challenge.
class.
Kind of, yeah. It's not like, hey, Ajay, you do the first 3 and I'll do the last 3 and then we'll compare. No, but yeah, you can work together on it.
We wouldn't have Ajay. We'd kick him out.
Bad example, yeah. That would be more productive if he's not in the room. Okay, now here's part 2. Part 2, you will actually run an experiment. Ultimately, the part 2 is I'm going to give you a sheet of paper, I love to do this, with an unknown acid on it.
Oh.
You're going to find 2 things. You're going to find its molar mass and its Ka value.
Ew.
You have to do a titration with that. That means you need sodium hydroxide and a burette. You're going to make the sodium hydroxide.
Yes.
And when you make a sodium hydroxide solution, you need its precise concentration. That means you need to standardize it.
Oh.
We're going to start with that tomorrow. I'm going to have solid sodium hydroxide in the room. I'm going to have burettes and graduated cylinders and balances and all the things that you would need. Bring your own calculator. All the things that you need to make up a sodium hydroxide solution. I'm going to give you an approximate range to make your hydroxide solution. So yeah, there's all these steps. They're not terrible. In fact, you've done them all before. You're going to make a Ugh. It didn't tell you have to make a sodium hydroxide, but you do. You're going to have to make a solution of sodium hydroxide, standardize it, and so then you're going to use the titration of sodium hydroxide with a standard acid. I'm suggesting use sulfamic acid. Then you'll know the concentration of sodium hydroxide, and you'll use it to titrate the weak acid. We're going to have, for the first time ever in this class, some pH meters. I don't think we've used pH meters yet this year, have we? So we've got different kinds of pH meters for the first time this year.
Especially in
For the first time ever in AP Chemistry, we have multiple sections running at the same time. So that means we need
You
a
messed
lot
up.
of equipment. For a lab like this, it's something we have to consider. So some of the stations are going to have computer laptops with a pH meter plugged into it that will read the pH and graph it for you.
No
Those
way.
are so nice. I'll probably give those to Mr. Hevel because he's the more senior member here and he deserves it.
Mic drop.
He's paid his dues.
But we have Ajay as a junior member.
Oh gosh, we have
Junior
Ajay.
member.
That's a handicap. Maybe I'll lobby for.
How does he
If we
respond?
don't have the computers,
With
though,
laughter.
don't feel bad. We will have these benchtop pH meters that you just have to write out what the pH is at different data points. Then we'll plug that into Excel, which I will try to have another set of laptops in here to do that for, and you'll have Excel make the graph for you. That's not terrible. That's not bad.
That's boring.
What?
Boring.
It's not long enough. I don't think it's boring. You'll get through it fast.
Yeah, don't complain about it, man.
So that's part 2, where you're going to find the Ka and the molar mass of an unknown acid. I don't think we have to identify the acid. I think it's just find the Ka and molar mass. Then finally, number 3, I'm going to give you a diprotic acid. That's what I was just talking about. You have to find its Ka1 and Ka2. Using your sodium hydroxide solution to use in part 2. So you won't have to make 2 different sodium hydroxide solutions. You can use them both. If you mess something up, there will be enough that you can do a second trial.
Shania, we better make a lot.
So tomorrow I'm going to tell you what part is going to be part of the write-up and what part is going to be the handout.
So bring up the lab notebooks.
Yes, starting tomorrow, have your lab notebook with you. Yep. All right, gang, everybody good? Should we stop now?
Can you go back to the was it polyphotic essay?
Yeah, sure.
We only have 40 seconds left before it reaches 45 minutes.
Oh, good deal.
Is there anything you would like to say? Final words.
What is this?
You're running out of time.
Again, anybody have any final words for Shania or anybody else watching?
I love watching.
This is going to be an interesting video. What do you want to say?
Didn't have anybody absent in the second hour, and then this hour she's the only one. So, okay, that's it.
Okay, 5, 4.
I wouldn't stop. Just end